This is the first lesson of a new unit where you will learn about a family of functions that plays a central role in mathematics: exponential functions. An exponential function is a function of the type f of x equals a to the x, where a, the base of the exponential, is a non-negative real number, and x is a real number. That's what's new. What is the meaning of an exponential with a real number at the exponent? For example, what is the meaning of 2 to the power of pi, or 5 to the power of root 2, or any other exponential when we have a real number at the exponent? We do not have in Algebra 2 the mathematical tools to understand this notation fully. So we will have to assume the existence of real exponents and accept that the rule that governs exponential notations are also valid for real exponents. For example, a to the x times a to the y equals a to the x plus y is also true when x and y are real number. This is a big jump, but it's also easy to make because we are very familiar with the rules of exponent, and these rules do not change when the exponent becomes real. In the entire unit, we will focus in particular on the main property of an exponential function. They increase or decrease at a constant rate of change. We will see what that means. In the first lesson, we will go over 4 examples that can all be modeled with exponential functions. We will not, though, define what an exponential function is until the 3rd lesson in this unit. To master the content of this lecture, you must be familiar with percent increase and percent decrease. Let's begin with the first example. So in the first example, we will assume that you have a successful consulting company and you are given 2 options for a 30-day contract. In the first option, you get $100 the first day, $200 the second day, $300 the third day, so on and so forth for 30 days. With this option, you get to keep each day's earnings. In the second option, you get 1 cent the first day, 2 cents the second, 4 cents the third, 8 cents the fourth, so on and so forth, for 30 days. With this option, you don't get to keep each day's earning. You only get to keep the amount on the last day's earning on day 30. Here's the first question. How much would you make at the end of the 3rd day with option 1? So what's going on with option 1? Well, on day 1, we make $100. On day 2, we make $200. And on day 3, we make $300. So at the end of the 3rd day, we would have a total of 100 plus 200 plus 300, that's $600 at the end of the 3rd day. All right? With option 2, on the first day, we would be computing with 1 cent. On the second day, we double that, that's 2 cents. And on the 3rd day, we double it, that's 4 cents. Now, we have $0 in our pockets. We have $0 in our pockets because we do not keep the earning on each day, but this is the amount that we would have to double at the end of the 3rd day. Okay? All right. Pretty big difference, right? $600 in our pockets, double 4 cents. Let's go to the second question. Same question at the end of the 5th day. So with option 1, let's go a little bit faster now. What are we adding? We're adding $100 first day, $200 second day, $300 third day, $400, and $500 for the 5th day. This is $1,500. So in 5 days, we've made $1,500. We have $1,500 in our pockets. With option 2, what are we doubling at the end of the 5th day? So we have 1 cent on the first day, we double it, that's 2 cents, we double it, that's 4 cents at the 3rd day, 4th day, 8 cents, and then 5th day, 16 cents. So on the 5th days, we are doubling 16 cents. We still have nothing in our pockets, while with option 1, we have $1,500 in our pockets. Let's continue. All right, so we know what to do for option 1. We just have more numbers to add, right? It's 100 plus 200 plus 300 plus etc., etc., etc. What's on the 9th day? 9th day, it would be $900, and on the 10th day, it would be $1,000. Now, if you use your calculator to add that, you will find $5,500. That's what we would have in our pockets at the end of the 10th day with option 1. Okay, what's going on with option 2? Well, with option 2, we double, right? We started with 1 cent and then we double to 2 cents. We double to 4 cents, which gets doubled to 8 cents, 16 cents, so on and so forth. The question is, what would be the amount on the 10th day? I don't want to do that 10th time, and then if I have to compute at the end of the month, that's going to get really tedious. I need a quicker way to get at the amount I'm doubling at the end of each day, right? So at the end of the 2nd day, I have 2 cents to double. At the end of the 3rd day, I have 4 cents to double. At the end of the 4th day, I have 8 cents to double, and then 16. We can see 2, 4, 8, 16. They are all powers of 2. 2 is 2 to the first power. 4 is 2 to the second power. 8 is 2 to the third power. 16, 2 to the fourth power. How about on the first day? Does it work? Well, we just cover 0 power, right? This is 2 to the 0. And so we have a relation between the number of day, this is day 1, day 2, day 3, day 4, day 5, right? We have a relation between the number of day and the exponent that I'm put at the power of 2 right here, right? It's 1 fewer. So for day number 10, I would have to double 2 to the 9th power. This is cents, right? 2 to the 9th power. This is cents. So what is 2 to the 9th power? Let's check it out. 2 to the power of 9 is 512. So on day 10, we have 512 cents, which is $5.12. Okay, so it looks like the difference is pretty important between option 1 and option 2. In option 1, at the end of 10 days, I have $5,500 in my pocket. In option 2, I'm just doubling $5.12 to figure out the amount on the 11th day. That's a pretty substantial difference. Let's move on. Okay, same question now with 15 days. So what do I do with option 1? I have to add 100 plus 200 plus etc., etc., etc. Plus on day 14, I would have 1400. And on day 15, I would have 1500. Every day, it increases by $100. If you take your calculator right here, you would find $12,000. $12,000 at the end of the 15 days in your pocket. All right. So now let's see with option 2, what amount you would be doubling on day 15, right? So you start on day 1 with 2 to the 1 minus 0, right? So this 2 to the 0, that's 1 cent. And then on day 2, we are going over the pattern we just saw. 2 to the 2 minus 1, right? That's 2 minus 1, 1. 2 to the 1 is 2 cents, right? The pattern works. And on day 15, you would have 2 to the 15 minus 1. Now, 15 minus 1 is 14, and 2 to the 14 is 2 to the power of 14 is 16,384. Now, don't forget, this is cents. $16,384. So in dollars, it is $163.84. Here we go. Still much larger with the first option. All right. So which option would you choose? Well, we are halfway through the month, right? We are halfway through the month. With option one, we have $12,000 in our pockets at the end of the 15-day, right? Halfway through the month. With option two, we are doubling $163.84 to figure out the next amount on day 16 that I have to double. So, which option would you choose? Well, that's a question for you to decide. Let's move on. Let's look at the end of the month. Option 1. At the end of the month, how much would you be looking at? So 100 on day 1, 200 on day 2, and then at the end of the month, on day 29, you would have 2,900, and then on day 30, you would have 3,000. So if you add all of these numbers together on your calculator, you would find $46,500. Pretty nice contract for 30 days, right? Okay, with option 2, don't forget, you are only keeping the last amount on the last day. The last day is day 30, and you remember how we computed the amount. You have to look at 2 to the power of 30 minus 1, and this is going to be in cents. So what is this? 2 to the power of 29. So in cents, it is, ooh, that's a big number. Let me report this number. So we had 5, 3, 6, 8, 7, 0, 9, 1, 2. What is that in cents? It is 536 million cents and some other stuff, right? And so what is it in dollars? It is 5,368,709 and 12 cents in dollars. So actually, option 2, which seemed to be increasing very slowly at first, in the end is more than 115 times what option 1 is. Wow, that's a pretty big difference. Let's move on to the next example. What's going on in the second example? You are investing $1,000 in an account that earns 1% interest at the end of every month. First question, what is in your account at the end of the first month? So how do you compute interest rate, right? So that's pretty simple. You take $1,000, that's what you invested. It's not going to disappear. It's still in your account. And you have to add 1% of $1,000. So to compute interest, you multiply 1,000 by 1% of it. That's how you do it, right? But actually, we can approach the problem with a gut understanding of percent. These numbers are very friendly. 1% means 1 per 100. That's what it means, percent, right? For every $100, you have 1 per 100, right? So 1% of 100 is 1, and so 1% of 1,000 is how many 100 in 1,000? 10. So basically, you're just adding $10 to the original investment, and that is $1,010. Okay, now I want to approach the problem in a more formulaic way. It's not going to be based on this gut understanding of a percent, but it will allow us to quickly get to any other amount at the end of any other month. Let's go over it. So let's take again the operation we performed. We had 1,000 and we added 1% of 1,000. 1% is 1 over 100. That's what the symbol means. Or in decimal form, it's 0.01. So this operation is 1,000 plus 1,000 times 0.01. Here, I want to factor 1,000. Let me quickly remind you how you would factor an expression like this. So here, A plays a role of 1,000 and 0.1 is played by x, right? So how do you factor a in this expression? It's a times, okay, times 1 plus, this is a plus right here, plus x, right? So it's a times 1 plus x. Okay, well, let's do it here. So what do we have? We have 1,000 times 1 plus 0.01. So what is that? This is 1,000 times 1.01. And you can check on your calculator that this is actually 1,010. Okay, but I'm not interested in that. What I'm interested in is this expression right here. Let's move on to the second question. Okay, second question. How much is in your account at the end of the second month? So what do? You take the amount that you had at the end of the first month and you have to add 1% of that, right? So how to compute 1%? You multiply this by 1%. Okay, so if you take your calculator, you will find that this is $1,020.10. Okay, now let's go over the same process we just went over in question 1. What is this operation? This is 1010 plus 1010 times 0.01. If you factor 1010, you will have 1010 times 1 plus 0.01, okay, which is 1010 times 1.01. Okay, so far that's what we did before. But now remember where 1010 is from. 1010 was 1000 times 1.01. That was 1010. And so you multiply this by 1.01, right? And you get what? So you get 1000 times 1.01 times 1.01, where you can use the exponential notation. 1.01 times 1.01 is just 1000 times 1.01 squared. This is what you have at the end of the second month in your account. So again, it's a little bit more mathematical, less understanding, but this is something we're going to be able to generalize. Next question. Okay, the next question is at the end of the third month. Okay, so now we know what to do. You take the amount that you had at the end of the second month, which was 1020 and 10. And you add to that 1% interest, right? So 1020.10 times 1%. So if you take your calculator, you will find that this is $1,030.301. So it's like 30 cents, right? We should round down, I guess. So this is 1,030.30 cents. We cannot, I'm not sure what it means in terms of money, right? Okay, now let's go over the same process we've been over twice. Let's look at this phrase right here. This is 1020.10 plus 1020.10 times 0.01. If you factor 1020.10, it's 1020.10 times 1 plus 0.01. So this is 1020.10 times 1.01. And now, if you remember this expression from the previous question, this was 1,000, which is, by the way, the original amount, times 1.01 squared. So you take that and you multiply by 1.01. So what do we have? We have 1,000 times 1.01 cubed. And that's at the end of the third month, right? That's at the end of the third month. So we start seeing a pattern, right? You take the original amount, which is $1,000, and you multiply by 1.01 raised to the power of the month that you are considering, right? And so we can write a general formula that would represent how much is in the account at the end of the nth month, right? What would it be? It would be 1,000 times 1.01 to the power of n at the end of the nth month. That's what it seems to be like. All right, let's move on to the next question. At the end of the 6th month, all right, let's apply our formula. At the end of the 6th month, we have 1,000 times 1.01 to the power of 6. So what is that? 1000 times 1.01 to the power of 6 is this amount. So we're going to round it. That's going to be 1061 and 52 cents. So it is about $1,000, 61 and 52 cents. Here we go. The next question is at the end of the first year, right? So how many months in a year? 12. So it should be 1000 times 1.01 to the power of 12. Okay, so what is that? 1000 times 1.01 to the power of 12 is 1126 and 82 cents. I'm going to round down this number because I don't believe a bank would have the generosity of rounding up. So I said this is $1,126.82. Okay, let's move on to the next question. At the end of the second year, now remember, when we use the formula 1000 times 1.01 to the n is in month, right? N is a number of months we're considering. So how many months in 2 years? 24, right? And so I should be looking at 1000 times 1.01 to the 24th to answer the question. And this is $1,269.73. Okay, let's move on to the next example. In the next example, we are investing $1,000 in an account that earns 12% in 1 year. Now, you remember in the previous example, it was 1% every month. So at the end of 1 year, it's like 12%, right? Okay, we'll see. So let's see. How much is the account at the end of the first year? So it is $1,000 that we invested plus 12% of 1,000, right? So this is 1,000 times 12%. Okay, so what is that? This is 1,000 plus 1,000 times, in decimal form, this is 0.12, right? Okay, I could take my calculator right now, but I really want to go over that formula again. Let's factor 1,000. This is 1,000 times 1 plus 0.12. And so it is 1,000 times 1.12, okay? When you look at this number is an increase of 1,000. This is an increase of 1,000 by 12%. Okay, this is a pretty simple amount to compute. It's $1,120. Okay, now let me remind you, in the previous problem, at the end of 12 months, we had $1,126.82. I had it rounded it down. So what's going on here? When I increase by 1% every month, I have this amount at the end of 1 year. How many months in a year? 12. 1% every month, it's like 12%. But actually, it is not like 12% because if I increase by 12% in 1 year in this case right here, I have $1,120. So why do I have more in the first example? This is something you'll understand throughout this unit. It's called interest on interest. Let's move on to the next question. Okay, how much do you have at the end of the second year in this third example? Okay, so how do we compute that? Well, we look at the amount we had at the end of the first year, which was 1120, and then we add 12% of it, right? So it's 1120 times 0.12. That's 12% of it. Okay, let's factor 1120. That's 1120 times 1 plus 0.12, right? And so this is 1120 times 1.12. But then again, if you remember how we got 1120 was 1000 times 1.12. That was 1120. And you multiply that again by 1.12, so you will find 1000 times 1.12 squared. Again, the same pattern we had noticed in the first example. And if you take your calculator, you will find $1,254.40. Once more, I would like you to compare it with what we had at the end of 2 years, but with the first model when we had 1% every month. We had found that at the end of 2 years, we had $1,269.73. So again, 1% every month, monthly, seems to be a better option than 12% yearly, okay? This is something that you will understand throughout the unit. Let's move on to the next example. Okay, the last example is about a beverage that contains 120 milligrams of caffeine. This is a good, strong cup of coffee. Each hour, the caffeine in your system decreases by about 12%. How much caffeine is in your body after 1 hour? So how do we compute that? Well, you started with 120 milligrams, but this time the amount decreases. So you have to subtract 12% of 120, right? So if you multiply this by 12%, now remember, 12% is 12 over 100, so it is 0.12. Okay, so it is 120 minus 120 times 0.12. Okay, you know the drill now. I'm going to factor 120, and so I will have 120 times 1, but this time is a minus because I'm decreasing, minus 0.12, right? And so what is that? This is 120 times 0.88. All right, if you take your calculator, you will find 105.6 milligrams of caffeine after 1 hour. Next question. Now, how much is left after 2 hours? So to compute that, you take the amount that you had after 1 hour, which was 105.6 milligrams, and you have to subtract 12% of that amount, right? So it's 105.6 times 12%, which is 0.12. Now, I'm going to factor 105.6, and it is going to be times 1 minus 0.12 right here. 1 minus 0.12 is 0.88, so it's 105.6 times 0.88. On the other hand, 105.6, I landed on that by doing 120 times 0.88, right? Taking away 12% of 120, and then you multiply that again by 0.88. So what you have is 120 times 0.88 square. So we see the same pattern, except that this time, because my amount decreases, I multiply the original amount by something that is smaller than 1. In the first two examples, we were increasing. It was an investment. We multiply by something that was above 1. If you take your calculator, you will find 92.90, I'm going to round up this time, 93 milligrams. This is a rounding, okay? Okay, next question. So to answer the question 3 hours, I'm going to be looking at the pattern I just landed on, which is the original amount times 0.88. That represents the factor by which 120 decreases, 12% decrease, raised to the power the number of hours. So if you take your calculator, you will find that actually this is about 81.77 milligrams, actually 78 if I round up, milligrams of caffeine left in the body. Last question is after 10 hours. So again, original amount times 0.88 because I have a decrease of 12%, and how many hours later? 10 hours later. And if you take your calculator, you will find that this is 33.42 milligrams of caffeine after 10 hours. All right, I hope this video was clear. Thank you for watching.